One-step inequalities, only adding and subtracting. You're going to notice a real strong similarity between one-step linear inequalities and one-step equations. The process of doing inverse operations remains exactly the same as one-step equations, two-step equations, etc. The only difference is we're going to have to read our solution as something different, and we'll go over that in just a second. So we're still solving a problem in reverse, and you can see the only thing that's changed is we have inequality symbols. And we'll talk about what those mean in just a moment as well. So with that being said, let's go over some example problems of one-step inequalities, and so you can see the similarities, and then we'll talk about the responses. So you can see the x minus 7, we're going to do plus 7 on both sides. And you could write this problem with an equal sign and then throw this inequality symbol in at the end if it makes you feel better. And then eventually you could work yourself into only having the inequality symbol. So negative 12 plus 7 will give you negative 5. And what this says right now is negative 5 is greater than x. This is where this kind of starts becoming a little more complicated than an equation, because equations only have one correct answer. Now, whenever we read an inequality, that means it could have a lot, and it's going to be limited to where those answers can be. One thing algebraically that I would suggest is always writing variable first. So x and negative 5, you can see how the inequality symbol is pointing at the x. So whenever I flip the whole problem, I'm going to flip that too. What this says is x is less than negative 5. So if we were to put this on a number line and we had negative 5 marked here, we'd have an open circle over negative 5 because we're not including negative 5 as one of our solutions. And it would be everything less than negative 5, which would be negative 6, negative 7, negative 8. So these are all responses in this direction, for as far as you can think, that would be good as a response or solutions for making this statement true. Negative 6 is less than negative 5, true. Getting rid of a positive 15, minus 15 on both sides. That is going to give you x is less than or equal to negative 15. Now, to just put this on a number line to, review and go over open, closed circle, direction it's going, etc. This is a good idea. X is less than or equal to negative 15. That means negative 15 can be included as one of our solutions because negative 15 is not less than, but it is equal to negative 15. So that'll give us a closed circle there. And everything less than negative 15, which would be negative 16, negative 17, negative 18. A very simple mistake to make is whenever you're thinking less than a negative, that you start counting the opposite direction, like negative 14, negative 13. No, that is more than. The more negative something is, the less value it has. So positive 17, positive 17, negative 17, positive 17 goes to 0. It's good. A is greater than 1. Just to put that on a number line, positive 1. It is not including 1. It's everything that is greater than 1. 1.1 would be a good response. That's true. 1.1 is greater than 1. 2, 3, 4, 5. So open circle over 1 because we're not including 1. And everything greater than, which is going to be in that direction. Plus 6, plus 6. You can see that nothing is changing so far. N is less than or equal to negative 8. And we plot that on a number line. You're going to see very similar stuff to the ones before. Okay, so that's going to be N is less than or equal to negative 8. So that includes negative 8. And we're talking about everything less than. So less would be more negative, negative 9, negative 10, negative 11, which would be in this direction. So once these things get plotted, then it kind of gives you an idea for what solutions could possibly be.